Hello my dear students, welcome to Physics is Fun. Today we will discuss a very interesting problem of two monkeys. So we have a monkey A whose mass is 5 kg and this monkey A is trying to climb up a rope, and the tail of this monkey A is being held by another monkey, a smaller one, whose mass is 2 kg. So this small monkey whose mass is 2 kg is holding on to the tail of this bigger monkey whose mass is 5 kg. And this monkey is trying to pull up this monkey as well as itself up along the rope. Now you can very easily understand that when the smaller monkey pulls the bigger monkey's tail, so a tension is created, right? So here, whatever tension is created, the tensional force which is created here on the tail of this bigger monkey, that tensional force can have a maximum value. Okay, it should be less than or equals to 30 Newton. That is the tolerance limit of this bigger monkey. The bigger monkey can only tolerate up to 30 Newton tension on its tail, not more than that. It can be less than that. Okay. Now, question is that what force should this bigger monkey apply on the rope in order to carry monkey B along with it? Okay. So, this monkey A is applying some force in the downward direction, and whatever force it applies is converted into tension in this thread. So tension in the thread, if I say that it is T, right? This monkey has mass 5 kg, so definitely its weight is 5 into 10, so we can say 50 Newton. 50 Newton is the weight of this monkey. And then there is a tension because of the pull of the smaller monkey. Okay, so we can call this one, suppose I am writing it as T dash. Now if I consider the smaller monkey, its mass is 2 kg, so its weight is how much? 20 Newton. Its weight is 20 Newton. And this tensional force, which is a stretching force, if I say this is T dash, so that T dash is basically pulling it up as well. Now these two monkeys, they are actually climbing up the rope, and that climbing up along the rope, suppose I am considering that both of these monkeys are going up with a uniform acceleration, so I may say that it is going up with some acceleration A. Okay, so this monkey is also going up with some acceleration A. So if I write the equation of motion consulting these free body diagrams, what can I basically say? I can say that T minus 50 minus T dash is equals to mass of this monkey into acceleration. So T minus T dash minus 50 equals to mass of this monkey is 5 into acceleration. Okay. Now if I say that the maximum tension that it can tolerate on its tail is 30 Newton. Okay. Suppose I am considering that it has a maximum tension that it can tolerate, I am putting that value 30 Newton. So whatever, you please understand, whatever force the bigger monkey applies on this thread, that is converted into tension. Okay. So from here what we can say? We can say that this T is equals to T dash plus 50 plus 5A. So I am calling this one as equation 1. If I consider this one, what can I say? So I can say that this T dash is T dash minus 20. T dash minus 20 is equals to, its mass is 2 kg, so 2 into A. So basically T dash is equals to 20 plus 2a. Okay. What is T dash? This T dash is nothing but, let me write this one as T dash. This T dash is nothing but the tension in the tail of the bigger monkey. So if T dash is equals to 30 Newton, the maximum limit of tolerance. So then what will happen? 30 equals to 20 plus 2a. So it would imply the value of acceleration is 10 by 2, which is 5 meter per second square. So this is the maximum value. So if we put this acceleration's value in equation 1, so if we put equation 3 in 1, then the value of T will be how much? See, T dash, right now the maximum tolerable limit is 30 Newton plus 50 plus 5 into 5. That means 25. So this will come as how much? 80 plus 25, 105 Newton. Okay. This 105 Newton, what is this 105 Newton? The 105 Newton is the tension in the thread which is being pulled by the bigger monkey. This. And why is this tension created? Because the bigger monkey has applied some downward force. The bigger monkey applied some downward force which I am calling capital F, and that is converted into tension in this thread. Okay. So basically, how much force has the bigger monkey applied so that it can pull up this smaller monkey? 105 Newton, right? Provided the tension on its tail is having a maximum limit of tolerance of 30 Newton. Okay. So this is one side of the answer only. Now, if this bigger monkey climbs up along the rope with uniform velocity, that may happen. It is not applying a very large force. It is just moving upward with uniform velocity along with this smaller monkey. By doing so, it will make the value of acceleration 0. And if that acceleration is 0, so if this monkey is going up along the rope with 0 acceleration, then what will happen to equation 2? See, equation 2 will tell us that this T dash is equals to 20 Newton. And if T dash is 20 Newton, then equation 1 will tell us that T is equals to 20 plus 50 plus 5 into 0, which is nothing but 70 Newton. So what is the moral of the story? The moral of the story is that when this bigger monkey is trying to pull up the smaller monkey by applying a large force, and if it wants to have the accelerated motion, basically that enhances the tension on its tail. See, the tension on its tail, T dash, is 20 plus 2 times acceleration, right? So if this bigger monkey is going up along this rope with 0 acceleration, then tension is 20 Newton, but it can tolerate a maximum up to 30 Newton. So if the value of T dash is to be 30 Newton, then it has to go up with a maximum acceleration of 5 meter per second square. It cannot go up along this rope with an acceleration which is greater than 5 meter per second square, because then otherwise this T dash will cross that limit of 30 Newton, which this monkey can tolerate. So basically, if T is 70 Newton, so what do we know? So therefore what we can say that the force that it can apply is 70 Newton. So there can be a range between 70 Newton to 105 Newton. The monkey it basically has a range of possibilities between two extremes. What are the two extremes? One extreme is that Monkey A carries monkey B, goes up along the rope with a constant velocity, zero acceleration. And in that case, it experiences a tension on its tail which is 20 Newton within its tolerable limit. And for doing that, it just needs to apply 70 Newton. Or monkey A climbs up along the rope along with monkey B, applying a force of 105 Newton, and by doing that it basically accelerates at a uniform rate of 5 meter per second square and experiences a maximum tension on its tail whose value is 30 Newton. Okay, so therefore the force that the monkey can apply, that monkey A can apply, so what will be my final answer? So if I say, my final answer will be like this, that this capital F that the monkey A can apply, it can have a maximum value, the force that it can apply, it can have a maximum value of how much? 105 Newton. It should have a maximum value of this, or I should say that it is less than equals to 105 Newton and it is greater than equals to of 70 Newton. Okay. So within this range, monkey A needs to apply a force. If it applies 70 Newton, it will go up with uniform velocity. If it applies 105 Newton, it will go up with a maximum acceleration of 5 meter per second square. And in between that, anything is possible. Suppose monkey A climbs up with monkey B with an acceleration of 2 meter per second square. If it is 2 meter per second square, 20 plus tension is 20 plus 2 into A. Okay, so 20 plus 2 into 2, 24 Newton within tolerable limit. Quite possible. Acceleration cannot exceed 5, but it can have value between 0 to 5. So if acceleration is 0, then it is applying a minimum force, and that is how much? 70 Newton. And if the value of acceleration is 5, it is applying a maximum force, and what is that value? 105 Newton. So that is the range of force which monkey A can apply in order to pull monkey B along with it up along the rope without having its tail torn off from its body basically. So I hope this very popular problem of H.C. VERMA is clear to you. It has cleared some fundamental concepts of free body diagram. Have a good day.